Okay, so chapter 6, math 2, we're doing number 11. This is really complicated, but it actually preps you for the next chapter. So I'm really going to be insistent that you actually work all these out. It says determine whether or not the two triangles in each pair below are similar, not congruent, just similar. If so, create a flowchart to show your reasoning. If not, explain why not. So it says they are similar. Be sure to check create a flowchart. And then this says similar by angle-angle association. Be sure to create a flowchart. I'm going to create the flowcharts because the reality is it's all wonderful if you know how to do the similarity part. You can check, but you need to create the flowcharts. That's all of chapter 7. So we're going to start with the first one really quickly, and I'm going to mark in different colors why these are similar to begin with. So the first thing you'll notice is that these two are the same. Okay, so that means angle B and angle E technically are congruent because they are marked with the same information. So we don't know anything about A and D. I don't care how much you want to tell me. If you don't know anything about which way these lines are going, the ones that are vertical right now, or they look vertical, you can't tell me that A and D are congruent yet. But you do know something very specific, and you know vertical angles. So this angle in here is going to be the same as this angle in here. Right there. All right, so far, okay, we got that. But what else do we know? Okay, now, me in particular, I would say, oh, well then, the other angle has no choice but to be also A and D have to be the same. So you can create, a similarity between the two triangles based on angle-angle similarity, which is fine. I'm okay with that. I'm not going to do it that way only because it says in the hint, check to see if the ratios of the corresponding sides are equal. So what the problem wants you to do is it wants you to remember how do you check the ratios between two triangles to see if their sides are congruent. To see if the sides are proportional. So let's figure this out. Now, the 12 and the 8, as far as I know, they're in the same area. It looks like they're in the same area to me. So I would say, okay, well, then that must mean that 12 and 8 are somehow connected. So I'm going to do little tiny flowers around 12 and 8. Okay, now, if that's true, then the only other option to use is, okay, well, I can't use 18 because 18 doesn't have anything to check it with. So I'm like, no, that's weird. How does that work out? Okay, so let's check 12 or 27 and 18. Okay, all right, this better work out because I don't know what else to do if it doesn't work out. So I'm going to check 27 and I'm going to check 18. Okay, let's see. 27. I'm going to box this one and 18. Okay, I'm going to check it really fast. Okay, check the ratio. Ratio means a fraction. So is 27 over 18 going to be the same as, equal to, the two that I just did, which is 12 over 8. Okay, hopefully this works out. Yeah, because B and E are the same. Okay, so let's check. 27 over 18, is that the same as 12 over 8? Okay, well, simplify. So 27 over 18 is what? 3 divided by 3 divided by 3, right? So 27 divided by 3 is, actually we did divide by 9. 27 divided by 9 is going to give you a 3. 18 divided by 9 is going to give you a 2. Okay, is that equal to, see, 12 and 8 have, a 4 in common. Okay, well, 12 divided by 4 is going to give you a 3. And then 8 divided by 4 is going to give you a 2. Yes, they are proportional. The ratios are the same. So now you know that you can create a side, angle side, pink side, right, angle B, and then purple side, similarity between the two triangles. So I'm going to do I'm going to make a flow chart for that. This is going to be a side, angle, side, similarity. All right, this is what we want to get to. Okay, so we need three things, right? Okay, so we're going to get through things. If you do the circles, you can do the circles right now. Okay, all right, so this is how I do this, okay? We'll see. If you don't agree with my methods, at least you can come up with your own. So 27, 27, 27, 27. Okay, so we know that AB, here's what I do. Okay, we know that AB is going to be equal to 27, all right? And we also know that DE is going to equal to DE is equal to 18. All right, so this is your given, this is your given. I might be doing a lot here, but that's okay. All right, now we also know that measure of angle, we know this right away, so we can just do one bubble for this. It makes it really convenient. We know that angle B, and I'm going to take a shortcut, angle B is equal to angle E. I'm not going to call it by the three letters. And this is a given, all right, because they are labeled, right? Angle B and angle E are the same. And then we need one more float. We know that, let's see, what did I do? BC. Okay, so we know that BC is equal to 12, and we know that EC, please pay attention to the way that I wrote the letters, is equal to 8. All right, so BC is 12, EC is 8. So there's the three that we're going to start with. Okay, those are the givens. Given, right? Comes with the info. And then we can shorten this. Okay, so if that's true, we know that, well, this stays pretty much the same, so it works out okay. We know that the ratios, right? So AB over DE is the same as 27 over 18 is the same as 3 over 2. Yay! And then this one, BC over EC, the same as 12 over 8 is the same as 3 over 2. Yay! Okay, so this is where I have an issue. The book says that this is really just calculating, right? But I really want to know what you're calculating. So I told my students that the reason you're doing this is to find the ratios. So, what did we put? Oh my goodness, I can't remember what we put down. So the book says calculate. So I don't know if your teacher just wants you to calculate. But I'm find the ratio, finding the ratios of sides, right? So this is the same thing. So ratios, side ratios. Okay, finding the ratio of sides, side ratios. All right, so from here we have, oh look, this is the same. Oh look, this is the same. That was the same. So now we know that triangle, I'm going to go in order. ABC is similar to triangle DEC. And then this is by side angle, side similarity. There's the flow chart. Okay. Now, the second one is going to be a little bit different, but it's kind of about the same thing. So you need to press pause if you need to get this down. And it needs to look like this if you're doing it this way. And I need to get a second piece of paper so I can do flowchart number 2. So like I said, if you need to press pause now because I'm about to switch it out. Okay, so flowchart number 2, okay, looks like this. It says parallel lines are given special angles. Which angles are these? So this is quite different, okay, but it will give us the same things. We have, let's see, 5, 6, and 4, and this triangle only has 3. Okay, so, and we cannot say that it's 4 and 3, and you can't do that. You need at least 2 sides to tell me ratios between sides. This one, we had enough sides to go around. This one, the triangle on the right-hand side doesn't have enough sides, so we need to figure it out. Okay, now, let's see, parallel line, there's the transversal. So this angle in here, W, and this angle up here, Y, are going to be congruent because of alternate interior angles. Okay, that's perfect. All right, now, what else do we know? From here, we can say the same thing on the other ends. So you can say, oh, look, it's the same thing that I did in the first one. There we go. what do you call those? Okay, we're going to write that up in a second. So now we know that it's similar by angle, right? We know by default, technically, this angle at the top is probably going to end up being the same thing as this angle down at the bottom because it just ends up being that way. So if all your angles are equal in two triangles, then they will be similar no matter what the sides are. So all you need are two angles because the third one is the same by default. So we're going to write these up. Okay, so first bubble, we're going to put the first thing. Do we have anything that's labeled that we just used? There are sides labeled, but we didn't really use the sides, so there's no reason to talk about WV or WX or YZ or anything like that. So we can jump right to the fact that these two are parallel. Those are the things that are given to us that we can use. So it gives us, I'm going to do this in black, okay, that VW, I should say, is parallel to YZ. It's parallel to YZ. Okay, this is a given. All right, now, and that basically, now we can write the next thing that we did, which was talk about those pink angles right here. So that gives us, personally, I think, that, okay, so that gives us that angle W is going to be congruent to angle Y because of alternate interior angles. I'm taking shortcuts because I don't want to write too much. All right. And then the other thing we can safely assume is the part about the purple angles, right? So the purple angles, I'm going to go with they're intersecting, right? So I'm going to say, I don't know, let's say that VZ intersects WY. And that's also a given. All right. So that means you have two intersecting segments. Right? So what you're going to get is that angle VXW is going to be congruent to angle, we got to go ZXY by vertical angles. Okay, so there's your two angles. So now you have triangle. Let's go in order. Here we go. VXW is similar to triangle ZXY by angle similarity. Oh, God, can't believe I did that. Similarity. Okay, so that was the flowchart, really fast for the two. Yay. Okay, so you can press pause, copy it down, make sure you understand what I did, where I got all the stuff from. All right.